Hey guys, welcome back. We're gonna make a ML Streamlit web app, um, and we're gonna do it from clustering your own DNA results from a DNA testing company you might have taken the test with. See my previous video for going more in depth on the k-means clustering. So with k-means clustering, we're going to give it cluster labels, and then we're going to cross-validate the classification model after the assigned labels. This is just holding the belief that these clusters I assigned, you assign as well, are 100% true. We're not scientists. We're just data scientists, machine learning engineers, just doing this for fun and working on our proficiency for web apps and being creative. That's all we're really doing. So there may be a lot of truth to it, maybe not. But remember, we're going to label and build a highly accurate classification model. Then we're going to deploy it using Streamlit. Anyways, guys, let's get started. As you can see my previous video. See my previous video for clustering, because we go more in depth on clustering your DNA results. However, I'm going to go through it, just not as much in depth. We're going to get to the classification and the deployments. And then we're going to talk a little bit about ancestry because it relates to the DNA data frames. Okay, so two previous videos before, they had different columns. They had one allele, and they had locus and frequency. So you see, so we couldn't compare that. But see my other video for Estonian DNA and Korean DNA, comparing them. Every DNA testing company usually has about the same columns. And if they don't, all of them, don't worry. This will give you a good idea. Like chromosome, RSID number to the SMP reference. That's what this is. The position, the allele 1 and 2. Some companies only have one allele. However, all companies that allow uploads and taking tests directly do usually have the code. If they allow uploads, they have the codes from other companies. Like this company example, you can take the test directly, and you can take it directly, and you can upload. I've taken directly and uploaded to quite a few. They all have one thing in common. I'm always the most Irish. German is usually 2. And South Slavic, they basically, each company has its own way of grouping. This divides Eastern Europe into 2 parts. Although some of these little ones are probably noise. Northern Europe, I always get that one because I always get a genetic community. Like on My Heritage and My Family Tree DNA, I got a community. Can't pronounce it, don't speak Finnish. Central European Jewish, Scandinavian. If it's under 2%, as we know in machine learning, there's a possibility it's noise, so the Balkan may not be. But here's the good thing about this company. They show migration patterns. You guys see? Like all them went to Ukraine. They here went to the England. Ireland Piers doesn't have any migration routes. Germany from here all the way to Finland through Russia. Anyways, guys, let's get started. Okay, the DF head, we got a label encode. These are objects. You guys see object? And then we're going to encode it, but as type string with the label encoder. Put it right here, or whatever you name your data frame, fill it accordingly. Okay? And then, yay, you guys see? It's encoded. And then 1 hot DF equals DF. Transform 1 hot. Now we're going to use PCA and k-means. but that is so we can assign it labels. Okay, so fit transform NCH fit. Okay. The explained variance. If you guys want me to go more in depth on that, see my last video. Okay. Okay, now this is to get the range. And as you can see, we have two debatable elbows. Traditionally, machine learning is supposed to go with the first real one. However, that's debatable because this one is more of an elbow. And if you want to give the model a little more leeway, you can do the little unorthodox method, just for fun. I put 4 right here. Y cluster equals model predict NCHS. There's the centers. Cluster equals Y cluster. The columns, we're going to label them clusters. You see what it predicted. Y cluster. You guys see? So we assigned it labels, and then we're going to merge later onto the data frame and label it. PCA, fit transform. Okay. As you can see, we assigned it PCA, not labels, but 2 extra columns. If you guys don't use these 2 PCA columns, you'll guys get a horrible model. Just letting you guys know. No matter what you use, naive, Bayes, it doesn't matter. Okay, XReduce, model labels on this index, markers red. Reduced X, DF. Now the new head. As you can see, we assigned PCA right there. Now we're going to assign the clusters to there. You guys see? There's the clusters. Now save it to CSV, but always add .csv. New one median. New one mean. You guys need to do new one min and new one max as well to get the range. Why do we need to get the range? You guys see right here with the PCA slider, we're going to skip ahead. You guys got to do the range because of the slider, remember? This thing right here. Okay. Okay. Just letting you guys know. Okay. Okay. X equals drop clusters, Y equals clusters. On an axis of 1. Test train splits, standard scalar, fit transform. Okay, and then we're going to use a decision tree classifier. Why? Because they're better on big data, and this is a pretty big file. Model fit, X train, Y train, predict X test. Now we're going to do some cross validation and an accuracy score. As you can guys see, the classification report to get the F1 score and all that, macro, because it's multi-class. Y true equals Y test, Y pred equals Y pred, comp mat. Okay. Scored pretty high, right? Now let's look at the confusion matrix. As you can see, it performed pretty well, huh? A little biased. However, this is just more creativity. Okay, pickling. We're going to dump the model. Now, guys, remember, DNA data in text format or whatever format, usually text, they have software similar. This is just the very basics when we get into clustering and all that, and then assigned to academic data sets. This company uses academic data sets. A lot of other companies use self-reported ancestry for certain ethnicities and regions. which is not as reliable because it's self reported. They're telling the truth as far as they know, but they don't actually know. Um, every company is different. Like My Family Tree DNA uses some academic data sets. You'll have to do research to find out which ones, it all depends. Every company's got their own method of genetic markers and all that. Every company does. Uh, and grouping with regions. Like as you can see with Ancestry.com and some of the other ones, usually Eastern Europe is all one. They haven't been able to divide it. And then this one hasn't been able to divide Scandinavian countries, I mean. And some of them can't distinguish the difference between these two. This is just a little demo. With all the tests I take, I end up getting Irish usually the highest, and then German before British. These are tied by 0.4%. South Slavic is usually up there. And Northern Europe, I've even gotten genetic communities from that as well. Southern Italy is new to me. I don't know if that's true. South Balkan, well, it's less than 2%, so it could be noise. Or it could be mistaken from this region, South Slavic, which it appears they all went to Ukraine. You see the migration patterns? Like through Russia, Belarus to Finland, Estonia. There to England, Ireland seems isolated. And then there to Germany. Okay. This is Central European Jews. This, I don't have that region. It was just putting it there. Yeah, but the French is like 0.07, so it's probably noise, I would tend to think. Okay. Okay. Okay, as you can see, we're going to pickle. And we just did that. Okay, before we get started, let me show you guys. We're going to deploy this on Streamlit Cloud. Okay. You're going to need your pickle file, whatever you named it, and then you're going to change that accordingly. Same thing with your app py. If you name this different, you need to let GitHub, you need to let Streamlit know which, if you don't name an app py, you need to run it into whatever you name it. Text. Okay. Do these, don't do versions. Okay, now your app py. Streamlit as st, numpy as np, string, pickle. Okay, put this right here, this set option. Uploader encoding false. Open, whatever you name the pickle file, RB. Pass that parameter. Name this whatever you want, header, text, header, text. Remember? Okay. Now, remember your data frame. Put all the columns right here. In fact, we're going to go over that real quick. And guys, remember, this is just suspending, this is just, pretending the idea that these clusters are 100% accurate and reliable when this is mostly for fun. Let's pretend these are the correct labels when they may be very close, they may be medium off, they may be 100% true, they may be half right. Anyways, the point is, we're not scientists, we're data scientists and machine learning engineers. However, we're just doing this for fun and having, exercising our proficiency in Streamlit and how you can apply this to maybe other projects as well. other multi-class classification projects where you need to deploy something, you know. Anyways, as you can see, PCA, RD. Remember I told you guys, you guys need to get the ranges, the minimum and the max, so you guys can do the slider bar. Remember? Because here is the slider bar. -5 and 5, -5, 5. These are the ranges for the slider bar right here. Okay? And whatever you want it to say, because you're sharing this data app with other people. So basically, they put in whatever in this range. Okay. And then your inputs, you're going to put them down here, what you put right here. And then the if Streamlit button model predict the inputs, flatten as type integer. If it's equal to 0, cluster 0. Equal to 1, Streamlit right, cluster 1. Streamlit right. If it's equal to 2, Streamlit right, cluster 2. Else, cluster 3. And then if name main, like you always do in apps. Okay, guys, here's the thing. You guys want to take a little demo through Streamlit? Well, let's do a prediction first. Cluster 2! Whoa! How about that? Okay. Anyways, guys, remember, I wanted to share with you guys, all you guys got to do is connect to GitHub. In one of my other videos, I show more in depth on how to connect to GitHub. In fact, the video for recommendation systems for Streamlit, the one with the Webtoons comics, that one teaches more in depth. Basically, all you do is either watch that video or follow my instructions right here. Just connect your GitHub to Streamlit Cloud when you sign up for an account, and then have it run in your app PY, and click deploy. That's simple. Or watch the video, Webtoons Comic Recommender System. Now, guys, if you guys are watching my channel for the first time, I have plenty of Streamlit apps, plenty of SageMaker pipeline videos, SageMaker models itself. You name it, I got it. This is usually on the machine learning engineering technical side, but lately I've been getting more on the data science side. Yeah, see my videos. I got mall clustering, all kinds of use cases for classification, regression. You name it, I got it. Reinforcement learning for trading. So check out my channel. If you're new here, feel free to subscribe. If you like the video, like it, share it too. If you're on my channel for the first time, I'm sure you're here because you needed something. I've got 121 other videos, all doing different things. So Streamlit for binary, regression, recommender systems, you name it. And then this one, multi-class, well, we labeled it from clustering. So let's just pretend that these labels we can verify are 100% true. And then now we made a classification model into a web app. Anyways, guys, just remember, my channel's got everything, and share with anyone you might need. I also got other recommender web app systems, and I got Recommender itself, content-based and collaborative filtering too. 2 for collaborative filtering. So you name it on my channel, I got it. Just hypertuning parameters, I got that too. Image classification, convolutional neural networks, or I also got image classification web app as well. I got deployments on Render Cloud, Azure Cloud, Google Cloud, And when I get it to enough subscribers, I'm going to do an ML pipeline on Google Cloud. You name it, I got it. I've also got Google Cloud deployments, 2 database videos, 1 Redshift, and another BigQuery. You name it, I got it. Anyways, take care, guys, and until next time, thank you. Bye.